Welcome students. In this class we will be learning how to handle questions which are way out of the ordinary. Now in this case we are expected to find the Laplace inverse of log of s positive 1 divided by s negative 1. Now this is unusual problem, right? This is usually they don't ask questions like this, but in competitive examinations and in graduate interviews and project interviews, they will ask questions of this nature. They will test you, specifically if you want to take up some research positions, positions or that has a scholarly bursary attached to that, then they would want to know what sort of candidates are coming in. Now for this question, what I would like to do is I would like to use the popular formula. We know that Laplace of t times f of t is equal to negative d over ds of f of s, formula that I would be using. With this formula, what I'm going to do is I'm going to now say, for example, from here you can clearly see that t times f of t is equal to L inverse of negative d over ds of f of s, right? You can clearly see that we are given to find L inverse of log of s positive 1 divided by s negative 1. So the question is, how are we going to bring in all of those things which we have seen? Foremost, what we need to do is we need to start out with this thing, with this statement. If f of t is given to be as L inverse of log of s positive 1 divided by s negative 1, if this is the situation, if I place a t on the left, this is going to be t times f of t. The moment it has a t times f of t, this has to be converted. So how does this change? So there's going to be L inverse of, you got a negative, this component is going to be negative d over ds of log of s positive 1 divided by s negative 1. This is all that you need to do. Once you place the t, this is going to become negative d over ds of this component, and you have to take the Laplace inverse of this entire thing. Now we know that log of a over b is equal to log a negative log b. We know that, right? So first, this is equal to L inverse of negative d over ds of log of a over b. This is going to be log of s positive 1 negative log of s negative 1. This is what I've got. Okay, that's fine. So now this is equal to L inverse of negative. Now I would like to take the d over ds inside. So this is going to be d over ds of log of s positive 1 negative d over ds of log of s negative 1. Okay, this is fine, and this is what we got, and that should be okay. Now if y is equal to log x, okay, what is dy over dx? Dy over dx is 1 over x, right? 1 over x times differentiation of x is 1. So you have to differentiate this. So this is going to be L inverse of negative differentiation of log. In fact, I should place a parenthesis like this. So because d over ds is actually an operator operating on this component, and d over ds is operating on this. Okay, that's fine. So this is going to be 1 over s positive 1 times differentiation of s. So you don't have to write it. It's just going to be 1 followed by, in this case, it's going to be 1 over s negative 1. So that is fine. Now you got this negative sign. So if I were to, I can just take the negative sign out because by linearity. So now if I take the negative sign out, I can now bring the L inverse inside. So this is going to be L inverse of 1 over s positive 1 negative L inverse of 1 over S negative 1. Right, this is fine. Now what is this? This is actually our shifting property. So this is going to be e raised to the power of negative t. Negative, this is going to be e raised to the power of positive t. Now you will have a negative sign, so it's going to be negative e raised to the power of negative t and positive e raised to the power of t. Now what I wish to do, I wish to rewrite this as e raised to the power of t, negative e raised to the power of negative t. Now if I were to divide by 2 and multiply by 2, it's going to be 2 times of e raised to the power of positive t, negative e raised to the power of negative t divided by 2. Now what is this? What is this entire quantity? Can you tell me? This is nothing but shinty. It would mean that we got t times f of t is equal to 2 times shinty. But we need only f of t, right? So this would mean that f of t is equal to 2 over t times shinty. So this is the solution for the question. Students,